Great. Welcome, everybody, to the Technical Advisory Committee for the DWR Bulletin 74 Well Standards Update. My name is Julie Lineback, and I'll be your facilitator for today. We are pleased to welcome you back. Some of you may be new. It has been a little while since we met, and we're excited to share some very new and upcoming information with you. I want to thank the TAC members for participating today and sort of coming back to us after a bit of time. I want to note that we have some observers on the YouTube live stream, as we have done before. TAC members are in this Zoom meeting. And for TAC members, I'll just say, and I'll probably keep saying, please go ahead when you enter and go ahead and edit your profile, which you can do by putting your cursor over your little video square, using the ellipses in the top right corner to open up your profile, and then edit so that you have your full name and affiliation. That's just super helpful. It have sort of like having a placard to be able to show everybody who's here. In addition, we will put the live stream link to the YouTube in the chat. You're welcome to send those to people who are not on the TAC, and they're welcome to observe this meeting. In their observation, they won't be able to see the breakout groups, which I'll go over in the agenda, but I just thought I'd note that for the YouTube observers from the beginning. As you may have noticed, this meeting is being recorded, and that recording will be available on the box site for the TAC members for future reference. It will not be available for the public. In terms of audio and technical assistance, when you join the meeting, everyone will be muted when they join. You'll have the ability to mute and unmute yourself. If you are joined by phone, you can press *9 to raise your hand and *6 to unmute. And then if anybody has other technical assistance requests, please put them in the chat and Tricia will help you out. Throughout the meeting, we're going to have quite a bit of information and presentations. We are going to go to a breakout group where you will be able to ask questions and give your input. And during that breakout group time is where I'd like to ask you to use your raise hand function. We've done this in the past. For those of you who have been with us all along, this will be familiar. All right, I think that's it for the housekeeping items. I'm going to go into our meeting objectives and agenda items. So for today, we have some big objectives here. We'd like to come out of this meeting with a shared understanding of the recommendations for ceiling materials from adjacent industries for application in the DWR Well Standards Update. We'd also like to come out of today with a shared understanding of the DWR Well Standards Update status and process. As I mentioned, we haven't met for a little while, so we need to just reorient folks to what's been going on. We'd also like to come out with TAC members being equipped to make informed comments and really serve as liaisons to their constituents for the public review period in next year. Also, DWR, we'd like for DWR to be informed with the TAC input, your input and advice on new recommendations for ceiling materials for the Well Standards Update and the public review period. So we have a lot of new information to go over today, and those are our objectives. In order to get there, we're going to use this agenda. We'll have some opening remarks from Cindy Messer with DWR. We'll review and just get grounded again in what is the TAC process and roles. And then we'll hear an overview of ceiling materials special review and an introduction of Donald Bruce, who's our special guest today. We'll also then go into an introduction to ceiling materials recommendations for DWR Well Standards Update and a summary of ceiling materials special review. Those two items will really form the meat of the presentations here today. And then we'll go into breakout groups, and the purpose of those will be to gather your questions and input. They are fairly short because we are going to then bring your questions back to the plenary, where our guest, Donald Bruce, will also be responding to those questions. And then we will go through these last couple items will be fairly short: schedule and plan to finalize the DWR well standards update, and then an update from State Water Resources Control Board from Aaron Budden. And then we'll close. So we have a packed agenda. And I think we'll probably just get right into it and welcome Cindy Messer, who is the lead deputy director of the executive division with Department of Water Resources. Welcome, Cindy.
Thank you. Thanks, Julie. And good morning, everyone. Very happy to be here. This is very interesting information and excited to learn a little bit more about what you all do as the TAC members. So on behalf of the Department of Water Resources, I wanted to thank you all for attending this special plenary meeting of the Bulletin 74 Technical Advisory Committee. As Julie said, my name is Cindy Messer. I'm one of the lead deputy directors here at DWR, and I'm currently working directly with the Division of Planning and helping to oversee some of the work that they're doing. So that's why I am here today to offer these opening remarks. Before I do, I did definitely want to acknowledge Camiar Gavechi, who I know is also tuned in to our meeting today. I know you all know Camiar, and he has traditionally opened these meetings up with remarks to kind of set the stage on things. I just wanted to acknowledge and thank Camiar for his leadership in this effort. I know it's been, a journey, and I know he has definitely helped to steer this, and as always been such an amazing resource and just a really good person to have be the face of DWR for these things. So thank you, Camiar. He has definitely stepped into a slightly new role for the department over the last 8 months. We've asked him to really help us get much more organized and proactive, if you will, on all things water, technology, innovation related. And that's what he's been diving in and digging into in the last 8 months, as I've said. So thank you, Camiar. It is definitely amazing in my mind to see such interest in the well standards. And, I'm grateful to have everyone here today. I know we have our topic of the day, which is our recent grouting review, expert review. And I know we're going to hear from Dr. Bruce on that. I did want to note that I was amazed to hear that this TAC group is made up of 81 members. That's pretty amazing. What a robust group. And talking to my staff at DWR, I really have gotten a better appreciation of just the breadth and level of expertise and knowledge that you all bring to this group and to the meeting today and to past meetings where we've really been able to engage. So big thank you to all of you for tuning in today. I know it's hard to carve time out these days to do anything. So thank you for being here. I'd also like to thank Dr. Bruce for his willingness to share his extensive knowledge on grouting and sealing materials today. And I know you're going to hear more from him, so just wanted to say thank you for his time as well. And lastly, I do want to say a big thanks to the entire Bulletin 74 project team, who I'm getting to know slowly but surely, under the leadership of Julie Haas. I just want to say thank you for all of your hard work and dedication to seeing this effort through and keeping us on track and moving forward. So thanks to all of you. The focus of this meeting, again, is to share with you, specifically the Bulletin 74 TAC members, what our DWR technical team has learned about sealing materials in their recent work with Dr. Bruce. We, as Julie mentioned, we do recognize this update has taken a little bit longer than we had hoped, but I think for our part, we really wanted to do our due diligence on this subject area and kind of increase our understanding, work with Dr. Bruce, get to a point where, which is today, where we are ready to bring a lot of really good information to the TAC members. So wanted to just thank you for your patience. This has been a little bit long in coming, and here we are. So very happy for that. I am told, I've again been talking to my team members, that past TAC focus group discussions have added an incredible value to the draft well standards. And we definitely are expecting that today will be no different. I know you have your breakout sessions. I think there will be a lot of really good conversation and discussion that will happen in those. Again, given the level and the breadth of expertise that's represented in this virtual room today, I know our DWR team has learned a lot from this TAC and the membership. So wanted to acknowledge that as we continue to move our way through to updating the well standards. And again, looking forward to the different perspectives that are going to be brought to the table today in these different conversations, and working through questions and conversations. I think this will only help to continue to improve the product that we've already moved so far forward. Shifting gears a little bit, maybe just for some of the new members. As a reminder, for those that are not so new, a bulletin, so for example, Bulletin 74, is the highest level of publication at the Department of Water Resources. These bulletins tend to have immense visibility, ranging from the public to the legislature, all the way up to the governor's office, which is the top of our chain of command. So this, we take this very seriously, and I think that is really, it's a testament to all of the engagement we've done with this group and others to really inform this bulletin and the update as we move forward, because we know it's important and it's going to be looked at very widely. The current version of Bulletin 74, which is 74-90, still draft, was published over 30 years ago. So we are due for some updates, and we're on our way to getting that done. With an increasing awareness generally of groundwater and the importance of groundwater in the state of California and the management of this resource, the need for these updated well standards has really been elevated in the last few years. The well standards are going to be a very important component of making groundwater sustainable in the state. So as I mentioned, we are taking this task at hand very seriously, and we've engaged a multidisciplinary team within the Department of Water Resources, along with our external partners. And our team includes groundwater experts, this term I'm going to totally butcher, and I'm sorry, cementitious materials experts, cathodic protection experts, and geologists. So a very deep bench of technical expertise within the department. We've brought the group together to ensure that this update reflects industry best practices, the current state of our knowledge related to groundwater protection and management, and to create an enforceable means to protect this resource. So DWR is definitely looking forward to finalizing the updated Bulletin 74. I know you all are going to talk about the timeline a little bit later. I'm just going to throw out that my understanding is our target for finalizing is sometime around spring of 2026. I know this is a lengthy timeline, so I did want to echo what Julie had mentioned, that we, in the interim, will have a public review draft. Right now, we're looking at around summer of next year. So we will have updated materials for this group to review, to weigh in on, as we move towards that ultimate 2026 goal of finalizing the bulletin. I'd also note that this update is going to include all 4 well types under one cover in one document. So that is going to be very different from past bulletins and documents. So it's a big leap forward. Once finalized, we will submit the standards to our sister state agency, the State Water Resources Control Board. I know we have folks in attendance today. They're going to share a little bit about their role, their involvement, next steps later in the agenda today. But I did want to acknowledge and thank them for their partnership as well on this. So I think with that, Julie, I am done and I'll hand it back over to you.
Great. Thank you, Cindy. Well, I'm going to just do a little reorientation of the TAC process and rules. And for those of you who have been with us, this will just be a refresh. And for those who may be stepping in to take over for somebody who left from your organization, we certainly can go over this in more depth, but this is a quick refresher. You may recall the phase 1 focus groups for the technical advisory committee covered destruction, large diameter wells and infiltration, sealing materials and placement, non-vertical wells, and water well siting and design. We covered that in 2021. And then we moved into winter of 2021 and 2022 with phase 2 focus groups where the TAC really provided advice on each of the 4 well types. And then moving into March 2022, the TAC reviewed draft well standards and sections of those drafts and provided comments. To remind everybody, the purpose of this technical advisory committee is to support DWR in developing updated well standards that are enforceable, protective, and based on current state of knowledge and best practices. And that is a big part of why we are here today, is that last part of the state of knowledge and best practices. In addition, DWR will submit the updated Bulletin 74 to the State Water Resources Control Board for adoption into a statewide model well ordinance. And of course, Aaron Button with the State Board is here to talk to us at the end of the agenda today. So the TAC plays an advisory role. It gives advice and input to DWR for the purpose of updating the well standards. DWR's role will be to identify issues in advance for technical discourse and deliberation by the TAC. And while the discussion has been rich and really wonderful and really a pleasure to learn from all of you, consensus is not expected in this role. DWR retains the final authority to create the package that is delivered to the State Board. This is about comments, the advisory role of the TAC, formal organizational comments reflecting positions on the updated standards are not expected. All input should be provided during the TAC focus group meetings and the plenary, as we are doing here today. And DWR may request written feedback on draft content. This is the current timeline and schedule. Cindy had just mentioned some of these items. We'll have a TAC meeting number 6, which will be a preview of public review draft, and we're thinking that would be July of next year. And then, of course, the public review draft release and the 45-day comment period, August through October, and then ending in October. The TAC responsibilities, this is a bit of a short list to just focus on what's in front of us, but of the TAC responsibilities that are relevant here today are reviewing. We ask that you review the references and pre-meeting information. Hopefully that has been done. We ask that you collect your constituents' input and represent their interests. And then disseminate information to constituents so that oftentimes many of you are serving as this conduit to larger groups of people, and thank you for doing that. In terms of external communications, we expect the TAC to communicate with your constituency and other TAC members, but refrain from sharing TAC materials with the media and do not attribute views heard in the TAC in the media. And that just allows us to have a really robust conversation here where people feel comfortable. So now I've gotten to the thank you. Thank you for the TAC members who provided questions in response to the preview document that was provided for this meeting. Several of you wrote emails with very good questions, and we've used those questions to shape the presentation that Dr. Bruce will provide, as well as some of the questions that will be posed in the breakout groups. So thank you very much for doing that. For those of you who maybe haven't asked your questions yet, please note them throughout the presentation and save them for the breakout group. That will be the time when you'll be able to have space to be able to raise your hand and pose your questions. So again, we're not going to do Q&A during Dr. Bruce's presentation, but we do want to have these smaller groups so that we can really make sure that we're noting what people have to ask. All right. I'm going to just review last the ground rules. These should be familiar for all of you. And I just want to say this group has just been such a pleasure to facilitate. You all have been so curious and interested in learning from each other. It's just been really fascinating for our facilitation team. And part of that is because you all are adhering to these ground rules. You're articulating your interests. You're treating disagreements not as battles, but as interesting investigations. You're speaking in I statements. This group and members have really demonstrated a lot of respect for each other's views. You're keeping your commitments for review. A lot of preparation goes into these meetings from all of you. And we've been keeping the meetings efficient, and you all are part of that. We've also just adhered to conversational courtesy, not talking over each other, and then having appropriate humor. So I really appreciate this group, and the focus groups have really adhered to these ground rules and made it quite a wonderful space for these rich conversations. All right, with that, I am going to hand it over to Julie Haas to introduce this next agenda item, which is the overview of ceiling materials, special review, and introduction of Dr. Donald Bruce. Go ahead.
Thank you, Julie. Well, Julie and Cindy did a great job setting the stage for this meeting. I just want to say welcome again, and thank you everyone for being here today. I'm Julie Haas. I'm the project manager for the Bulletin 74 update, and I'm supported today by my DWR Bulletin 74 technical team. Thanks, Julie. Most are here today, and you're going to get to meet them in the breakout rooms later. They are James Walker, who is the assistant project manager for the Bulletin 74 update. He's a senior engineering geologist. We have James Albertoni, senior corrosion engineer, Eric Gorman, senior engineering geologist, Jason Priest, senior engineering geologist, Mark Suverville, engineering geologist, Debbie Spangler, senior engineering geologist, and David Sullivan, associate corrosion engineer. So from mid-May through early August of this year, the DWR team held a series of meetings with Dr. Donald Bruce to gather his insights on the draft standards for ceiling materials. Donald Bruce is an internationally renowned expert in specialty geotechnical construction with a focus on drilling and grouting techniques, anchors, micropiles, deep mixing, cutoffs, and in situ reinforcement. Donald has over 40 years of experience in dam anchoring and works on projects throughout North America and 4 other continents. He is former chairman of the Geo Institute's Grouting Committee and honorary chairman of the International Society for Micropiles. He is also an active member of the Post-Tensioning Institute's Committee on Rock and Soil. He has approximately 300 publications and is co-author of Dam Foundation Grouting, which I can personally recommend, and a new book, Specialty Construction Techniques for Dam and Levee Remediation. He is the recipient of the Cap, Baker, and Terzaghi Awards from the American Society of Civil Engineers. Next slide. So prior to enlisting Donald Bruce's help, a little more than 2 years ago, our team engaged 2 cementitious materials experts within DWR's Division of Engineering, Joseph Burke and Tim Wheeling, who provided valuable input. Both independently recommended consulting with Donald Bruce to answer remaining concerns. The main areas of concern were sealing materials used in the unsaturated zone, sealing materials for deficient annular spaces less than 2 inches, and sealing materials for destruction. It took some time to get approval and go through the contracting process, and Donald's review finally began in May of this year. Next slide.
I would like to just make one announcement. We are just
Okay.
hearing that some folks who are not on the TAC are trying to get into the meeting and see the meeting. And I would like to invite them to go to the YouTube live stream link. We want you to be able to observe. We want you seeing this, and please go to the YouTube live stream link. And Julie,
Thank
sorry
you,
to interrupt.
Julie.
I will.
No problem. Okay, so if you can forward it one, oh, there you go. You're on the right slide. So the technical team met with Donald Bruce 7 times from mid-May to early August to vet his recommendations against their many decades of field experience. The grouting review was truly collaborative. Though Donald has decades of drilling and grouting experience, he does not normally work in the well industry. His willingness to learn the intricacies of well construction from our team, his enthusiastic sharing of his own knowledge, and his practical approach in all his recommendations have made our work together easy, enriching, and enjoyable. I want to express my deep gratitude to Donald for his generosity in sharing his knowledge across industries. It is not an easy task to stretch outside of one's comfort zone, and we are so happy that he was willing to do so. Next slide. So with Donald's help, in the next 15 minutes, we are going to present you the findings from the grouting review in an interview format with James Walker and myself asking Donald leading questions. The information we are sharing today has still not been fully incorporated into the draft standards. So we can't tell you exactly what the standards will say, but we can point you to what we are considering. While it may seem a little premature to hold this meeting in that regard, we wanted you to be in step with us in terms of foundational knowledge about sealing materials that are going to reshape the standards so that you can be better informed for the public review. During the presentation, we expect that each of you will be listening for indications of how your work will be positively or negatively impacted by potential changes in sealing requirements. As always, it is important for us to hear those impacts to your work. But I also ask that you listen in a curious way so that you don't miss out on learning about methods that may save you time or materials that may solve nagging problems. As practitioners, many of you have intimate working knowledge of these materials and their behaviors. We hope that through breaking down the science behind those behaviors, you may discover new strategies and solutions to meet your needs in a way that also protects groundwater. If time allows, we'll take clarifying questions during this presentation. We'll probably be limited on time, so please write down all other questions and bring them to the breakout rooms.
Great. Thank you so much,
Okay.
Julie.
Yeah, so I think maybe we have to go back one slide.
There's a next slide here.
This one, yeah,
Yes.
This is the slide. So before jumping into the technical questions, I wanted to start with a not so technical question. Well, it's probably a little bit technical, but Donald, to start us off, could you speak a little bit about changes that your geotechnical grouting industry underwent 10 to 15 years ago, giving us the history of how those changes came about and where the industry landed?
Certainly, Julie, and I trust that you can hear me okay.
Yes, you sound great.
That's fine. Well, first of all, thank you, and thanks, Cindy, for your very kind remarks. The pleasure has also been mine working with you folks. Due to my internet connection, which is really rather fragile here in Arizona, you will not be able to see me. This is probably a very good thing. So anyway, good morning, everyone. First, delighted to have been asked to assist the well industry navigate proposed changes. Over the course of this grouting review, I learned a lot about your industry and found that our industries have a lot in common, i.e. the geotechnical market in which I play and your own. First, I'd like to clarify exactly what I mean by grout and grouting. So, for example, a suspension of bentonite in water for us is just a slurry and not a grout. A mix containing cement is a grout. Concrete is not a grout. Sand cement is somewhere between grout and concrete, and in fact, in the industry is called a medium mobility grout. The activities and the materials that we use in sealing wells is very analogous to our so-called structural grouting, as used in ground anchors and micropiles and so on. And so, as Julie mentioned, we really hope that the lessons we've learned more recently regarding materials, methods, and best practices from these geotechnical grouting applications can also be used in our well industry to good benefit. So Julie mentioned this so-called revolution that we've had in the geotechnical grouting industry. Basically, for almost 100 years, there was a very sort of traditional approach to using certain mixes and methods, and the knowledge base didn't advance very quickly. This is particularly true in the case of grouting for dams. And one of the reasons for that, and I'm sure my contractor friends will recognize it, is that the specifications were very prescriptive and didn't really allow the contractor's scope in using their own researches and their own intelligences. And in fact, when the revolution began in the, say, the late 80s, early 90s, there were still a lot of pockets of resistance among more traditional specialists. And that kind of slowed the rate of advancement in certain states and in certain organizations. But I think it's fair to say that now these innovations are widely used and generally accepted in the grouting industry. Now, why did they happen? Why were they necessary? Well, there was failures. We all hear about these horrible case histories where the grouting was terminated only when the money ran out, as opposed to achieving good performance, or where the grouting had to be redone over a number of years simply because it wasn't effective the first time round. The other thing is that I think that we learned to understand the contributions of our colleagues in the admixture and the additive production industries, that they had been very active for many years, of course, in the concrete industry, with superplasticizers and retarders and so on. And then finally, the penny dropped with us grouters as well. And what was good enough for the concrete fellows is certainly equally good enough for us in the grouting business. So, as I say, it's fair to say that these radical changes have been embraced in the US as well as in Europe, of course, as well. And I really hope that you'll find interest and value in the technical content of this presentation and that it gives you food for thought. Thanks, Julie.
Oh, Julie, you're on mute. And I definitely want to hear what you're saying.
Okay. Thank you, Donald. That's really good background for us to have heading into the first technical question. So in updating the well standards, we've been hyper-focused on one property of sealing materials, and that is permeability. The idea being that if the annulus between the casing and the borehole is filled with lower permeability material than the surrounding formation, it will drive fluid flow outside of the annulus and back into the formation for natural attenuation. Without an annular seal, the process of attenuation would be short-circuited and fluids could enter the aquifer untreated. During discussions with you, Donald, we learned that to get to a low permeability seal, there are many properties of the sealing material that we should be looking at. please describe those mix properties that are most relevant to well construction and destruction. And for each property, please describe the field and or lab test used to evaluate that property. Thank you.
Okay, that's a very good question.
Okay.
So this answer might be equally long, probably longer, and some people listening in may find this rather either simplistic or well-known already, and it may be a bit hard going. But as you say, if we understand these different properties, then we will understand much better how we can improve the quality of the sealing, both in terms of material selection, mix design, and introduction. So I think most people on the call here will know what permeability is. It's just an index of how water moves through a solid. And so, for example, if we have a sand, the measure might be 10 to the minus 3 centimeters per second. If it was clay, it might be 10 to the minus 6 centimeters per second. And what we're looking for in a really nice grout is something that is maybe 10 to the minus 9 or even less. And that's perfectly achievable using the right blend of materials and equipment. How do we measure permeability? Well, we don't do it in the field. We do it in the lab with typical testing according to ASTM standards. So usual permeameter, the clock, and collecting the fluid and so on. In dam grouting, we measure permeability in situ in the field, but we certainly don't use techniques like this. Next. So another property, absolutely vital, is stability of the grout. And this applies to the stability of the fluid grout. And there are two things that we need to worry about regarding stability of the fluid grout. Next slide. Right, so one of them is what we call bleed. And basically we take a sample of the fluid grout, watch it over a period of maybe 2 or 3 hours until it fully hydrates, and we measure progressively the amount of water that is decanted to the top of that measuring cylinder. So this decantation occurs simply by the settlement of the individual particles. Now, bleed is not a good thing, because unless it can escape into the ground, into the formation, it will remain in place either as, if you like, little balloons of water or vertical ribbons. In either case, it has the potential to allow water to move through the system. Next slide. Pressure filtration might be something that you're less familiar with, and this is still test on the fluid grout. And basically, once we start pressurizing a fluid grout, this pressure filtration coefficient measures how well it retains the water, because the water is basically just a lubricant in the grout. And so if the grout can hold the water into the cement particles, and remember, grout is not a solution, it's a mixture of little, it's a suspension of cement particles and water. And therefore, if a grout is formulated that can hold in the water, that means that the grout can travel further and more efficiently. And if in fact we were thinking ahead to grouting very fine slots or perforations in casings, then an unstable grout in pressure filtration will just basically filter itself and smoosh over, that's a very technical term, the individual perforations, and therefore stop the grout escaping. So pressure filtration is not a routine QA/QC test, but it's what we would call a classification test, that at the beginning of the job, we do some test mixes, run this test, and be happy that our mix design had good pressure filtration resistance. Next slide, Judy. Homogeneity, a fancy word for saying we don't want any lumps in the grout. And this is going to be reflected in the kind of mixer that we use. For example, if we use a pedal mixer, which we'll discuss later, the Corps of Engineers recommends putting the grout through this 1/4-inch sieve to make sure that two things happen. One is that no lumps go into our grouting system and therefore cause blockages. But of course, if we do have lumps that are retained by the sieve, that means that the material that's gone through the sieve has a different water cement ratio, i.e. a higher water cement ratio than what we had intended to begin with. So this is a question of the grout property as well as its absence of lumps. Next slide, Julie. Thank you. I'm sure you all know what this is, initial and final set. It's common in our grouting industry that this is measured either by a pocket penetrometer or by the Vicat needle. As far as I'm concerned, a far more responsive and practical approach is shown on the left-hand side. You take a coffee cup, you fill it with grout, and you just watch what happens to it over a period of a couple of hours. And once you can't stick your thumb into it anymore, that's probably the initial and getting on for final set as well. So you, ladies and gentlemen working in the field, I would advise you just to be pragmatic about this and just take that little cup of grout and get a good visual demonstration of what it's probably doing in the grout. Next slide, please. Now then, specific gravity, extremely important. First of all, this is the tool that we use to measure it. Many of you who have worked in the oil field industry will know how to operate this. It's a very simple beam balance. It's a very simple test. It takes about a minute to do and is accurate to within 1%. And this gives you a measure directly of the specific gravity, call it density, of the grout. Now, why is that important? Well, when we think about it, the main components in the grout are water, cement, and probably sand. And the SG is very driven by the actual amount of these major components in the mix. So if you, for example, had a typical neat water cement ratio grout, say 0.5, you would be targeting a specific gravity, maybe 1.8, something like that. However, if you suddenly measured this and you found that you had a specific gravity of 1.4, that would say that the fellow who was running the grout plant got the water content wrong. And it's crystal clear. You can get specific gravity to within 0.02. And that's a typical operational variation. And that is more than enough to confirm that your batching quantities have been accurately done. Next slide. Now, maybe just a little bit too much for the beginning of a Thursday morning, but there is a logic in how you can calculate specific gravity. And Julie and I have done this in both units because I know that you're bilingual. So here's the metric way we do it. And then the next slide, which I'll hold for a second, is in our USCS. So if we go back to the previous slide, please, Julie. Thank you. And this is the way that I do it. And believe me, even though it's you're dealing with kilograms and liters and so on, it is just so easy. It is very easy in metric. So just walking through this slide a little bit, the third bullet there is a typical grout, your 10.3 SAC mix. So it would include for one bag of cement, which is 94 pounds, it would be 58 pounds of water and 188 pounds of sand. Now, as you know, we convert pounds to kilograms by dividing by 2.2. So then that one bag mix, if you like, weighs 155 kilograms approximately. Now we then take the weight and we divide it by the specific gravity, the solid grain specific gravity. And the beauty of the metric system is that water is 1. Cement is 3.15. Sand is variable, but we take 2.6. So you divide the weight by the gravity there, and you get the volume of these materials. So if you total the volume, you now have the weight of that mix, you now have its volume. You divide the weight by the volume, that gives you the specific gravity, the density. So now you're in the field and your target is a 2.12, and you routinely test that mix and you get 2.10 or 2.14, you know that your mix that you're injecting is exactly what you want it to be. And now, Julie, the next slide would be useful. Yeah, and this is how to do it if you really want to still do it in pounds and cubic feet and stuff like that. The key thing is that the SG is still the same, still 2.12. So which either way you do it, you come to the same answer. Apparent viscosity. Again, those of you who have worked in the oil field probably use this a lot. Basically, it's a funnel that you can see lying on its side there with a handle. It's got an aperture at the bottom. You take some of the grout, you pour it through the little mesh there. You put your finger first, of course, over the orifice at the end. then you take it away, you start timing, and you're timing the amount of seconds that it takes for 1 quart of grout to pass through. Water is about 28 seconds. Typical, what we call high mobility grout, would be anywhere from 30 to 60 seconds. Beyond that, beyond 60 seconds, this test is less reliable and less accurate. And in fact, it doesn't relate to very dense high mobility grouts. Typically, if you find that you're testing and it's more than, say, 100 or 120 seconds, that means that basically the grout's too thick to pass through the system. Next one. Other considerations, of course, for us in sealing would be shrinkage of the grout and its pumpability. So I think the next slide discusses shrinkage. No, I beg your pardon. Hold it there. That's fine. So shrinkage is determined by the water-cement ratio and by additives that we could use and by the type of mixer. So it's not a one-size-fits-all. It reflects a lot of different aspects. And likewise, pumpability, which is essential, of course, for good placement. This reflects what we call the rheology of the grout, i.e. the flow characteristics of the grout, which in turn is dictated by the type of mixer, the water-cement ratio, the length of injection, the speed of injection, for example, and the pump capacity, the grout line diameter, and of course the ambient temperature under which we're working. So again, pumpability is not a constant. It's something that we have to learn to live with and to adapt in the field in response to field conditions. Next slide, Jen.
Great. Thank you, Donald. We took just for, so all of our DWR team knows, and Donald, we took a little more time than we had thought on that particular question. So we might need to drop the last question or just move a little quicker. So this is the recap of what Dr. Bruce has just reviewed. And this will be helpful as we review. We'll put this up on the DWR TAC site, and as you review these slides, if you need them as a reference, you can go through them, but I won't spend time on them here.
Great, well, thank you, Julie. For the next question, at the outset of your review, Donald, we explained that there is a general desire for a predictable and straightforward permitting process for well construction and destruction, making prescriptive mixed recipes very desirable. However, we understand that in your work, performance-based grouting is the norm. This flexibility is acceptable because of the many quality control measures and on-site grout engineers who adjust mixes on the fly. We also recognize that level of sophistication arises from the relatively high risk that comes with working on dams and embankments. Given our desire to simplify well sealing, what are the best practices that we can take from the dam and embankment grouting world to ensure success in our industry?
Good. Thank you, James. And Julie, I'm aware that probably the previous question took longer than we had allowed, but there are so many fundamental things in there I felt it was useful for the team. All right, so James asks a very good question. In fact, there are 3 answers to this. The first thing is proper mixing. And this is probably going to be something that the TAC members will really have to grapple with, because high-speed, high-shear mixers are the norm in the geotechnical grouting industry. Not only for dams and levees, but for anchors and micropiles and so on. And these are, and I'll show you these now, in fact, if you pull up the next slide. High speed here, yeah, versus low shear mixers. Prehydration of bentonite is very important. We're going to discuss that later on. So what we call a high shear mixer, yeah, next slide would be fine, Julie, thank you, is shown diagrammatically on the left. The heart of a high-speed, high-shear mixer is that black star, or the discar, that's shown at the bottom there. And it spins around at maybe between 1300 and 1600 RPM inside a very tight tolerance chamber. And so the water and the cement are intimately mixed in that fashion. So the key thing to think about is this, that if you took all the cement grains out of one single bag of cement and laid them side by side, you would cover about 3 football fields in area. And your task is to wet that 3 football fields with 5 or 6 gallons of water. So that's why the colloidal high-speed mixer is so efficient and necessary for the low water cement ratio grouts. There are several suppliers in the US. There's also a very strong rental market for these units as well. Next one. Another kind of mixer that's used infrequently in our business is what's called a jet mixer. And here, as the name suggests, the water and the cement are just blended by a very high-speed jet of water. We typically use this for large volumes of bentonite slurries as used in diaphragm wall construction. It may not be applicable for our particular case. Next slide. And then the paddle mixer. Well, as you can see, there's paddle mixers and there's paddle mixers. The shot on the left-hand side, which I'm very grateful for and I'm going to use in other presentations, reminds us that typically handheld equipment like this would be regarded in our field only as acceptable for lab scale, bench scale testing. It wouldn't be acceptable in the field, partly because of the quality of the grout and also the volume of the grout and the time that it takes. One of the beauties of the high-speed mixer is it's very fast. You can assimilate a 3-bag mix in about 2 minutes. That's very quick. And on the right-hand side is a typical, if you like, a commercial grade, industrial grade paddle mixer. This one's produced by ChemGrout, who also do high-speed mixers as well. They're based up in Illinois. Very, very fine company. Next slide. Right. So mixing is one aspect to James's question. The second aspect is the water cement ratio. Absolutely fundamental. And I know we're tight for time, but I'll just walk through this very quickly. This is absolutely fundamental. This is the key to life. So along the bottom of this graph is the water cement ratio by weight. So it starts at 0.3 on the left-hand side, which is very, very low, and goes up to 1, and you could continue these graphs on beyond. So what does the change in water cement ratio do? Well, as we go from 0.4 up to 1, the bleed increases. So that's that graph that sweeps from the axis there up to 0.2. So that means that if you've got a water cement ratio of 1, 20% of that is going to be bleed water at the end of the day. What does it do in terms of strength? Well, there's the 28-day compressive strength. And you can see that as you increase your water cement ratio, you reduce the strength. Strength of water is practically 0, as you know. So why are we tempted to go with high water cement ratios? And the answer is that upper curve, which is resistance to flow, i.e., if you like, thickness. So there's no question that you put more water into the mix, you increase the water cement ratio, it'll be easier to pump. But that's a false promise, because you're paying the penalty for strength and bleed. You might be able to pump it quicker, but you're going to get a pretty rotten product at the end of the day. And also the water cement ratio controls permeability of the set grout, which is important. But typically the permeability of cement grouts is so low anyway that a change in the region between, say, 0.4 and 1 isn't going to be critical to us. So for once, this is a secondary consideration as opposed to the stability and the strength. I hope that's a good summary. Obviously, you probably want to have a look at this graph in your own time and just think about it. Okay, next slide. And then the third aspect of James's question is systematic QA/QC. QA, as we know, is what is done in terms of quality assurance by the owner or his representative. QC is what's done by the contractor in real time. And as I mentioned at the beginning, we can regard these QA/QC tests in 2 categories. One is what we call classification testing, which is done basically pre-production. But it could be you get on site on Monday, you batch up the first trial batch, you do these tests on that, and that should hold you for the rest of the project once you're satisfied that your performance criteria have been met. And then the second group is what you do several times a day during construction. Measure the SG with that baroid mud balance that we showed, and measure the viscosity just as a check that it hasn't began to overhydrate and that you can still pump it. So these are very, very valuable tests. Don't worry about the sophistication of the classification testing. Focus more on the routine QA/QC. Next slide.
Thank you very much. I am going to just allow this to populate for the summary and move on to inviting Julie Haas to ask the next question.
All right, thanks, Julie. And I agree with Donald. These first questions are sort of fundamental. And so spending more time on these, even if we have to sacrifice the last question, makes sense. So question 3, as you know, we originally included 3 types of cementitious materials in the draft standards: neat cement, sand cement with fine aggregate, and concrete with larger aggregate. After consulting with our Division of Engineering experts, we also entertained adding cement bentonite grout to that list. Cement with bentonite as an additive is already approved in Bulletin 7490, but it's not highlighted as a separate mix. We're going to talk about cement bentonite grout in the next question in more depth. But first, can you set us up for success by providing an overview of the different additives that are used with cementitious materials in light of the grouting properties that you discussed earlier?
Set you up for success, eh, Julie? That's a leading question now. Okay, so just a tiny wee bit of background here. For ground treatment, either injecting rock masses or soil, we don't use neat cement grouts anymore. That's a thing of the past. We use what are called balanced high mobility grouts. And these would comprise bentonite, cement, and water, but also, as we're going to see in a second, a viscosifier, which is a gum, and superplasticizer. So, for example, the bentonite and the viscosifier thicken the grout, but we need the super P then to make it more fluid. So we're basically balancing the impact of each of these different materials. And then in some cases, some contractors choose to use ash or silica fume and other materials like that. So let's look at bentonite. Very misunderstood in terms of its properties and what its purpose really is. But it's the bentonite that we use is the sodium montmorillonite clay, not the calcium, sodium. It reduces bleed in the grout. So basically these particles, when they're hydrated, act as little parachutes for the cement and stop them settling. But it does increase apparent viscosity, cohesion, and thixotropy. Typically in our HMGs, we're adding up to about 5% by weight of cement in a typical high mobility grout. Okay, next one. So superplasticizer. A typical one that's used throughout the country is a naphthalene sulfonate, which is made from trees. More recently, companies like Master Builders and so on have started using mineral superplasticizers in smaller amounts, very potent. So what does the super P do? Well, it coats each of the cement particles with a negative charge, and that causes them to repel each other, just like magnets. And so that makes them want to move around more. So it helps their mobility. Most super Ps will also retard hydration a little. And if you want to know how much to add, then you just phone Master Builders or Sika or the other suppliers, and they will typically tell you 0.5 to 2% by weight of cement, depending on how much extra fluidity you need. Next slide. Diet and gum. Now this is excellent. A more recent discovery in our grouting business. Diet and gum, also known as Wayland gum, is one of the components of what do you call it? A foodstuff. It's gone completely out of my head because I don't eat it. But it causes stability in the food stuff. And basically, instead of your container of, say, cream cheese or something like that, just being very fluid, it gives it body. So in our grouts, what we like about the gum is that it gives resistance to pressure filtration. I remember how important that was from earlier on. So basically, it helps to bind the water into the system. The material I was thinking about was yogurt. You check the label on a container of yogurt, and you'll probably find gum is added. Very small amounts, typically 0.1% by weight of cement, so you don't need a lot on site. Very easy to handle. It can either be fluid or it can be powder. Excellent material. Okay. Now then, Master Builders, one of the leading concrete and grout additive and admixture suppliers all over the world. They have a material called UW450. Other suppliers have similar materials. And this is an anti-washout agent, hence UW, anti-washout underwater. And it's used in fast flow conditions because, as most of you will know, if you try and put a normal cement grout in fast flow conditions, it will get extruded, it will get dissolved before it has time to fully hydrate. Again, check with the manufacturer, typically 0.2 to 1% by weight of cement. Now, the key thing about all these, and I hope they're not confusing all these different additives and so on, there are guidances provided in ASTM and in the Concrete Institute as well. The key thing is, from a practical point of view, if you are going to use different additives, different admixtures, make sure they're chemically compatible with each other. And you are best advised then just to go to one supplier for all your admixtures. That ensures that you have chemical compatibility between them all.
Thank you. All right, I'm going to introduce James to ask the next question.
Thanks, Julie. So bentonite is traditionally added to cement-based mixes per Bulletin 74 up to 6% by weight of cement used to improve fluid characteristics of the sealing mix and reduce the rate of heat generation during setting. You've explained the benefits, Donald, of mixing cement with high-speed, high-shear mixers and how bentonite as an additive can enhance certain properties of cement to allow increased water content without increasing bleed. Would you discuss the importance of bentonite prehydration in achieving a quality cement bentonite grout and how current mixing practices may not typically achieve a high-quality mix?
Certainly, James. And this is, again, a fundamental question. As I mentioned, there is an often patchy understanding of exactly what bentonite does and how it works. So this is a slide that I'm indebted to Julie for. But basically, you add water to bentonite, and the bentonite grains, they swell 15 to 18 times. So they're taking on a lot of water, taking up a lot of space. So they're quite hungry for water. Now, if you go to the next slide, then, if you use unhydrated bentonite, i.e. you just throw some dry bentonite powder into a grout mix, it can increase the permeability of cured cement. So this is a negative thing. And in fact, just adding bentonite powder to already cement water mix is absolutely a waste of the beneficial properties of bentonite, because the cement water reaction, as you know, is very alkaline, and that will inhibit the ability of the bentonite particles to expand and contribute. So you might as well just put in non-reactive clay. It would be a lot cheaper than unhydrated bentonite. So that's why we do two things. First of all, proper prehydration. This is what is really best practice. You mix in a high-speed, high-shear mixer. It'll probably take you a couple of minutes for a couple of bags to go through. Then hold that in a holding tank, agitated or bubbled, just to try and keep the whole thing going. And that should be kept in that condition for at least about 4 hours prior to introducing the cement. And that's based on precedent practice. Different mixer manufacturers will tell you you need 12 hours or you need 6 hours. But Haney, for example, the great Swiss manufacturer, they say that up to 4 hours is more than adequate. So what do we do then? Well, we take the slurry, i.e. the bentonite water slurry, and then drop it into the mixing tank. And then you add the cement to that, so that the bentonite's already underway, it's already bubbling away, and then the cement reacts in situ there to give a nice balanced grout. So again, that might be something new to you or something you really want to discuss and explore further. It's not as difficult as it sounds, and it's extremely beneficial in terms of producing high quality, stable grout mixes for sealing. Thank you, James.
Great, thank you. And now back over to Julie Haas for the next question.
Okay. When you started this review, Donald, we asked you to review the Nebraska grout study, since we were basing many of our limits on sealing materials in the uppermost portion of the well on those findings. In short, the Nebraska grout study observed bentonite slurries and neat cement cracking and desiccating in the unsaturated zone, Our reading of those findings was that those mixes had been negatively impacted by a wicking effect of the unsaturated zone, since findings were generally positive below the water table. Now that you've walked us through the basics of cementitious mixes, the contribution of each component, proper mixing and water to cement ratios, and desirable mix properties, can you put it all together for us by describing your thoughts about the Nebraska grout study findings?
Yes, I can. First of all, in full disclosure, I thought that the grout study was really an impressive in situ effort. I could only imagine how much it cost and the time and attention that was required. It was wholly admirable that the participants in the well sealing industry would cooperate financially and technically to conduct this extensive and very significant field test. However, and hindsight is 2020. If we go to, this is the slide. Interesting study finding there that the bentonite chips rehydrate, whereas the bentonite slurries did not if previously desiccated. So that's important, but that may be related to the fact that the bentonite slurries, the heavy bentonite slurries, were not prehydrated for long periods and were mixed in the paddle mixer. So there's a little reevaluation to be done there. The bentonite certainly was not prehydrated. We know from other geotechnical applications that stable, neat cement grout mixed in a colloidal mixer performs perfectly well in the unsaturated zones, as I say, in these other applications. What we had in Nebraska was a paddle mixer and relatively high water cement ratios. So between these two factors, the fact that the grouts that were produced seemed to be unstable and bled unacceptably is wholly logical. Another really important thing was that sand cement grouts are more forgiving than neat cement grouts in terms of water cement ratios and so on. I know that the contractors don't particularly like using sand cement grouts because they tear up the rotors and the stators of the Moino pumps. But if different pumps are used and different mixing methods are acceptable, then sand cement grouts have a lot of positives in our industry. And I'll just say one more thing, Julie, if I may. Between all of us so far, we've kind of crystal balled and said, if we were to do another phase of testing, another similar industry review, there are several points building on the excellent reports from Nebraska that we could use maybe to go in different directions and to explore other aspects of our grouts. But I don't think we have time to go into that just now.
Thank you. I will pass it back over to James to ask question 6 about heat of hydration.
Thanks, Julie. So Donald, we shared with you a recent project within DWR where rapid heat generation during cement hydration melted and deformed a casing for a would-be monitoring well. Our grouting expert with DWR's Division of Engineering did some detective work and quickly ascertained that temperature of the grout was the primary factor in the failure. Can you speak to the importance of temperature and other measures taken to control heat of hydration?
Absolutely, James. And Tim and his colleagues did a super job back analyzing what happened there. Heat of hydration, it's a natural phenomenon. It occurs. Cement and water is an exothermic reaction, i.e. it gives off heat. So you can't not have heat developing in a mix. And that is going to affect the fluid properties of the grout. And it's also going to affect the set properties of the grout. So really, it's very important. So how do we combat this practically? So many of the guidances that we have for processes like micropiles and anchors say that the grout temperature should never be more than 90 degrees Fahrenheit. How do we ensure that if we're working in the desert or we're working down in Florida or something like that? Classic defenses that the contractors are using is putting ice in the mixer, using water chillers, wrapping the exposed lines in wet burlap or reflective coatings, just to try and keep the heat away from the grout in the lines. And then always putting the cement and the bentonite and any sand in shady conditions, because these are the biggest components, as we said before, of the grout. And therefore, if we can minimize the heat absorption. That is very helpful. We can also use admixtures, as we said, as retarders, and this will help prevent cracking because the grout can hydrate without other things happening. We can substitute Portland cement by inert fillers. For example, sand, limestone. Many of you know now that we're dealing with type 1L cement as opposed to type 1-2. And the 1L has a substitution of limestone for cement. So that reduces the heat of hydration. For big bulk infill jobs that we used to do in the old days, we may have had something like an 8-to-1 ratio between ash, fly ash, and cement. We don't typically want to talk about fly ash too much anymore. One of the main reasons being that it's becoming scarce because nobody is burning coal anymore. So we're kind of devaluing, I think, de-emphasizing the potential for ash. And just as a practical point for folks in the field, initial set, start your timer as soon as the grout is batched. That's time 0. But if you're using a retarded mix, start time 0 for initial set when retarder has worn off. And you should know that because you're going to see a marked rapid increase in the marsh value. Okay, so heat hydration, very important, especially in a state like California with very high ambient temperatures in many areas. Okay, James?
Great, thank you. And now I will ask Julie Haas to ask the question about sand cement and ASR.
Okay, Donald, as part of your review, we discussed the classic 10.3 SAC sand cement mix, as well as mix 111, which is a sand cement with bentonite and superplasticizer that was developed for use in the geothermal heat exchange well industry. Sand cements have performed adequately even when mixed with a paddle mixer. However, our Division of Engineering recommended that we address alkali silica reactivity in the update for sand cement mixes. Can you take a minute to talk about 2 aspects of sand cement mixes? First, ways in which previously discussed rules and tests do or don't apply to sand cements. And secondly, explain alkali silica reactivity, or ASR, and the effect it has on cured cements and concrete.
Okay.
Please, thank you.
Right. Well, I'll be as brief as I can with this. So we know that when we put sand in the grout, it increases the internal friction. The sand typically doesn't react chemically, so it's purely a physical change that it's bringing about in the grout. And we use it to help combat bleed and shrinkage. And as we mentioned before, it's more forgiving in terms of variations in the water cement ratio. Also in terms of mixing, as you alluded to, Julie, the BNL tests produced a very good mix, the mix 111, and it performed adequately when mixed both in paddle mixers or colloidal mixers, although BNL did give the opinion that they preferred, for various reasons, to use the colloidal mixer.
Oh, so, Donald, just for everybody who's not familiar with it, BNL stands for the
Brookhaven.
Yeah, okay.
Sorry, I beg your pardon.
Okay. Do you want to say, okay, Brookhaven National Laboratory, and they're the ones that developed Mix 111. Okay, go ahead.
Yeah, thank you for that clarification. We often use these shorthands and we forget other people haven't seen the reports. So yeah, so sand, nothing against use of sand cement grouts. In geotechnical work, we rarely use them simply because of practical problems. But then if you have need for sand in our geotechnical applications, it means that you have probably very big fissures or pore spaces that you'd have to pay special attention to anyway. Now, the alkali silica reactivity is commonly referred to as the concrete cancer. And it occurs when the aggregate that is used is chemically reactive with the alkali fluids that are released during the hydration of the cement. So that's why it's called alkali silica or alkali aggregate reaction. To put this in perspective, many of the big dams in the Tennessee Valley area And also some dams in California as well have major problems with AAR. One of our biggest dams in TVA, Fontana Dam, was completed in the early 1940s. And what AER does, or ASR does, it causes swelling and therefore cracking. And that big concrete dam is still growing. You can accommodate it by cutting slots in the dam, to take the compression or the expansion, but you cannot stop it. It's an internally consistent, ongoing reaction. It doesn't need an external water supply to continue the reaction. So the effect on our grouts would be that if we don't use the right aggregate, i.e. if we use the wrong reactive aggregate, then we run the danger of our grouts cracking and expanding and therefore increasing in permeability with time. Cannot be stopped. Now, in my opinion, say once it starts, you can't stop it. So what do? You try and have strong prevention. So just in the same way that the contractor or the engineer would ask for certification on his sand supply or his cement supply in terms of grain size and chemistry and so on, I think it's also fair to put the burden on the supply industry, the aggregate supply industry, and say that as part of their routine certification, that they have to certify that the aggregate is non-reactive. I don't think there's any other way we can handle that, Julie.
Thanks, Donald. I think I might have cut you off when you were making an important point about the Brookhaven National Lab findings. Would you mind just summarizing?
Sure. I think what I was talking about there was the fact that the Lovely Mix 111 performed adequately even when a paddle mixer was used, but that the researchers noted a clear preference for the colloidal mixer on grounds of speed and quality and homogeneity. So I think that was the point I was trying to make.
Thank you. I appreciate that.
Great. Thank you very much. Okay, moving on to question 8, and this will be James's question on destruction via perforations.
Thanks, Julie. So many of our destructions are performed by perforating blank casing and or utilizing existing perforations in the well screen or vent pipe to pass sealing material from the inside of the casing or vent pipe to the annulus. We asked you about a couple of aspects of this type of destruction. First, our team could not find a basis for some of the rules of thumb for minimum perforation sizes to pass cement, such as for Mills knife cuts. ASTM D5299 recommends 4 rows of perforations, several millimeters long, and 15 perforations per linear meter, but provides no reference as to why. So we asked you to weigh in, noting that the Mills knife perforations are about 3/8 of an inch wide, shot perforations are 0.3 to 0.88 inches in diameter, and the smallest off-the-shelf monitoring well screen openings are 0.01 inches, and cathodic protection well vent openings are typically 0.01 to 0.02 inches, but can be as small as 0.006 inches if cut with a laser. Second, please contrast gravity grouting with a tremie with pressure grouting with packers. And third, how can we better control, to the extent possible, where the grout goes so that it doesn't follow the path of least resistance and fill up the most permeable zones, i.e. aquifers?
Yeah. How long do we have, James?
We actually only have about 6 minutes if we're going to skip. We had questions 9 and 10. So I know we do want to give people time in breakout groups. So, but I know there's a lot to cover in this particular answer. So I defer to Julie Haas.
All right.
I think Donald's up for the challenge.
Okay.
Go ahead, Donald.
Oh, thank you. You're very kind. I have 6 minutes. I've only got 12 minutes of information here. Okay, so the first part of James's excellent question, aperture size. And he noted correctly that there doesn't seem to be any quantitative backup to what people have been doing for years. The way I looked at it is this, that if you look at the grain size of the grout, we know from Fisher grouting, which is basically the same as trying to push grout through the slots there, that you have to have an aperture that's at least 3 to 5 times bigger than the maximum particle size of the cement. So therefore, in a typical type 1 cement, the largest 10-15%, which control penetration, the particle size is about 0.002 inch. So therefore, if you take the rule of 5, that means that the opening has to be bigger than 0.01. And so that would be at the lower end, Julie, and that would be a thickness or an aperture, which if it were finer, would not be able to transmit cement grout. And then the STM rule of thumb is quite fine with me. I think that makes a lot of sense. I've got no basis to challenge that at all. But the bottom line for me is just use the largest perforations that are practical. So if that's with the mill's knife and so on, or standard PVCs or whatever, just use the biggest perforations you can reliably and economically handle, because that's going to allow you to pump quicker and pump faster, and might be a little bit more forgiving in terms of the homogeneity of the grout. I believe you've got some photographs coming up, Julie. Yeah. So those nice big shot perforations, no problem getting grout through those at all. The mill's knife and so on. I'm sure that a lot of people on this line know all about that. The key thing is just to get the biggest perforations you can. And then we look at the scheduled PVC. We all know about these. Again, the finer the slots, the finer the perforations, the more emphasis you have to put on the quality and the homogeneity of the grout. Thank you. Okay. Very quickly here, James, if you'll forgive me. Again, this is a question of terminology. In our industries, gravity grouting simply means filling a hole with a tremie, either from a dish at the top or with a pump that's just giving enough pressure in the pump to force the grout through and then push it up the outside of the tremie. So that's what we call gravity grouting. Pressure grouting is where we have a confined situation, where we have either a packer or some kind of cap that allows us to put excess pressure on the grout to force it in and out of the formation a lot quicker and a lot more economically. So I would hope, I noticed reading through some of the documentation that there was perhaps a confusion in the use of these terms. And I understand that Julie and her team will be standardizing the terminology for mutual benefit here. Okay. Next slide, please, Julie. Thank you. And I understand this is from our previous document. And again, it just illustrates, in this case, annulus grouting with either gravity method on the one side or with confinement through a packer on the other. So that drawing here will have to be updated as well, of course. We talk about packers as if everybody knows all about them. And here they are on the left-hand side. These are tools that just go down the hole. We expand them either with air or water or hydraulic fluid, depending on the manufacturer. And then the grout line passes down through the middle of that black thing and emerges at the bottom. So you're basically providing confinement to the system by using this packer. And once you finish grouting, you extract it. Well, you try and extract it, hopefully, if you don't leave it in the ground too long. And then the cartoon on the right-hand side there is just an illustration of how we might have variable ground conditions, and we want to make sure that we don't lose all the grout into the most permeable conditions. And I think we come to that in the next slide, I think, Julie. So we have to be careful. Yeah. So one technique that we typically use in our grouting is sealing in lifts or stages. So if we had a hole, say, 100 feet long, and we look at what the geology is, and if we found, for example, that we had a very permeable layer halfway up, then we'd grout only halfway up, because the grout's lazy. It just wants to go, wherever it wants to. It's very fluid. And so there we would stop at that point, let the grout set, and then maybe even use a different grout for the next stage, thicker grout or grout with sand, for example, so that we would know that we had thoroughly treated responsively each of the different ground conditions. If we don't do that, then the grout's going to go preferentially. We also have a phenomenon which we call sagging, which just means that before the grout has completely hydrated, it can drift away into permeable ground conditions. And you might not notice that by observing the grout at the top of the hole. So you might just be left with a hole in the grouting program halfway up the annulus, for example. And that's because the grout will bridge between the pipe and the ground condition higher up. So again, it may seem an overcomplication, but it should be driven by the ground. And if there is a potential danger for bridging or excess grout takes, then this would be the defense against it. Okay. Next slide.
Great, thank you so much. This is a summary of the answers to the question, and this is the time that we had planned to go into breakout groups, and we could return to those other last two questions in the next plenary if they are relevant, or if we don't have other major questions. But I assume that we are going to have some really good questions from our TAC breakout groups.
Yes.
So if
Julie,
yeah, go ahead.
One option would be to spend just a couple more minutes and have Donald just quickly go through the answers to the next questions, and
Sure.
we could just skip the question slide.
Let's do that.
I think they're pretty brief.
Great. I will go
Donald,
to
does that sound workable?
Yes, I'll do
Okay.
whatever you
All right.
feel is for the group. So this is 9.
yes.
Well, we know from our deep tunnel grouting that if you've got a grout line that's 1.5, 2-inch diameter or more, we can pump for tens of thousands of feet. We can either retard the grout, i.e., it'll just stay fluid for long, or we can do what we call inhibit the grout, which means that we basically put it to sleep and then we waken it up when we want it to be injected behind the tunnel lining, for example. So the key thing here is proper formulation, proper mixing, use of admixtures or additives, and specify the time the grout must remain workable. And that will be related to the contractor's equipment in terms of mixing and pumping capacity, and in terms of the length over which the grout must be injected. That's a quick summary there, Julie. Next slide. Yeah, we don't see grout lines of this small diameter in our business. This is for the GHEW particularly. And I would just caution that that's a very, very small diameter for cementitious grout. I mean, think of it this way, you'd need a fair bit of pressure to pump water through that line over a long distance. What is it going to be like with a particulate grout? It's going to be even more difficult, prone to blockage, and be very slow, and you need a pump of pretty high capacity if the copper line could withstand the pressure. That's a difficult one. Okay.
And this is our question 10 about graphite as inert filler. And I'll just give you the slides for the answer here, Donald.
Thank you, I appreciate that. All right, so we don't use graphite in the geotechnical business, and that's not for any technical reason. I think it's probably fair to say it's just a paradigm of the industry. We use other things, like sand or ash or limestone filler, clay. So the key there, I think, is just performance-based. If any of the contractors on the line would care to use graphite, I have absolutely no technical objection to that at all, provided that any mix design that was formulated had testing of the performance of the material, and in particular, the shape and the gradation of the particle sizes, and then the quality control over material supply. So how sure would you be that supplier A is going to give you graphite or sand or ash of certain properties on Monday, and then when you reorder on Wednesday, it's going to be the same, because shape and gradation will control the rheological properties of the grout. So again, performance testing, up to you folks, but make sure you get consistency in the supply of the materials.
Great, thank you. That was a whirlwind tour through the last questions and answers, so I appreciate that. And now we are going to move into breakout groups, and the purpose of these is to be able to hear your questions. DWR really would like to hear your questions. We'll be documenting those. We'll be bringing back to the plenary 3 of your top questions back to Dr. Bruce to be able to answer back in the plenary, so everybody can hear those questions and answer them. I am expecting there will be more than 3, and we will document those, and DWR will see how they can answer them in the meeting summary, which will be then posted to the TAC box site. I want to let you know also that there will be a Kearns and West facilitator in each breakout. They will document questions. DWR will pose some question prompts that they have developed in response to some of the questions that they've received. And the breakout groups will be recorded for note-taking purposes, but those will not be posted to the TAC box site. For those of you who are watching on YouTube live stream, the breakout rooms will not be streamed. So those of you who are watching on the live stream, you'll just take a break during this time, and then we will be back for the plenary, and you'll get to hear Dr. Bruce talk about the answers to the recap of the questions. So I am going to let you know also that you're pre-assigned. So you're going to just receive a note in your dialog box on Zoom that is sending you to the breakout group. And I think here it comes. There we go.
Julie, and James, thanks very much for your facilitation and your organization this morning.
All right. Thank you, everybody. I hope you all had great question and answer sessions in the breakouts. I believe that we have captured some questions for Donald Bruce to answer in coming back here to the plenary. So what I'm going to do is start with group 1. And what we'll do here is we'll have the DWR lead from each breakout group just pose the questions to Donald Bruce, and then we'll have Dr. Bruce answer here. So I'm going to introduce James Walker with DWR to take care of the questions from group number 1.
Thanks, Julie. So the first question was related to the availability of certified materials. This was specifically in relation to the ASR certification that was brought up earlier in the presentation. And confirming the question was related to where that certification is coming from. So in this case, is the certification coming from the batch or mixing plants, and is that broadly available within California? Donald? Yeah, sorry.
Read the other one too, James. Sorry, I didn't want to interrupt you.
No worries, yeah.
Okay, and I think as we discussed in preparation, James and Julie, that I'll be glad to tell you what I know from technical viewpoints and things like that, but anything to do with, the certifications and the policies and so on, I'd really rather not touch. But the whole point of question 1 is that when we order, say, concrete from a batch plant, every mix that is delivered, every truck that is delivered, has a mixing or a batching form associated with that batch. And that will be related to the type of sand and the type of cement and the type of large aggregate. Previous to that, in submittals by the contractor, he will have identified the sources of these materials. And that would include, for example, on the cement side, the grain size analysis, the chemistry, the setting time, and so on, all the things that would comply with ACI. And likewise, on the aggregate side, it's common to provide a gradation curve showing the different sizes of materials that have been used. And in my opinion, and sometimes I have seen this, in fact, James, is that a statement is required from the batch plant, and therefore he would get that from the materials supplier regarding the inert nature of the aggregate. So again, as I said before, I'd put the whole weight of proof and certification on the batch plant, knowing that he is going to have the same certification backup from the supplier.
Great, thank you. And then let's see, the next question was also related to ASR, specifically clarifying that the aggregate that we're discussing is what's being mixed, what's being added at the batch plant. And noting also that as we're destroying wells, there's no control over the aggregate that's already in the hole. And is that going to be a concern? Because, we don't know what's down the hole, what the sealing material is going to be in contact with, what the characteristics of that material are going to be or are. Is that going to be a factor to consider?
Yeah, I thought that was an excellent point that your colleague brought up there. I was predominantly or exclusively just thinking about aggregate that would be used in the preparation of the grout, or the backfill material, the sealing material. I hadn't considered the possibility of potentially a reactive aggregate already in place that would then have to be grouted up. And I don't know what you can do about that, quite frankly. I simply don't know.
Okay, something we'll take back.
Yeah.
And then finally, regarding what's being done currently in the grouting industry in terms of practices or standards to make sure that mixtures are added properly.
Yeah, I thought that was an excellent question as well, and very good input. Because the offshore industry, of course, is probably even more tightly controlled in terms of its quality and its processes than onshore. Our standard of care is that, bearing in mind as well that we typically have a static batch plant that's on site. Often it's covered against the elements and so on. And you have different tanks or different holders for the different materials. And so at the most sophisticated, you have water meters controlling the amount of water that's going in, or the amount of bentonite slurry that's going in, weigh batching of the cement. And then depending on the nature of the admixture, if it's fluid, say like the Super P, then you have a graduated cylinder that is added by hand or can be added automatically, almost on a little timer basis. If it is solid powder, as most of the gum supplies are, then typically what happens is that there's a little sachet, a plastic bag made up in advance, precisely weighed with the amount of that additive that has to go in to a certain batch size. And so this is the perfect way of controlling, given, as your colleague said, that there's a very small amount, relatively speaking, of additive that is necessary or used. And therefore, even if you were to go 50% above that, it's going to make a big difference to the mix, and especially with the viscosifier. So the standard of care typically is to mix up in advance, or to make up in advance little bags, and the grouter, the man's in charge of the batch plant, pops one in the mixer per batch that is formulated. It's just done that way.
Great, thanks, Donald.
And I think, next stage down, James, as well, just thinking the practicalities, Our colleagues are not going to have these big, sophisticated batch plants in the field, but the same principles would apply. That for every bag of cement or every 3 bags of cement, whatever it is, whatever the unit is, there is this amount of additive, this amount of super P, or this amount of other additive that has to be added per mix in sequence. So it's you can check it off on a little check sheet. Water, cement, bentonite, super P, viscosifier. Just a little tick mark. That's the best QA you can do. Best QC you can do. It's got to be measured. You can't just eyeball it in. That's for sure.
Absolutely.
Oh,
Precision is key.
it is. It is, especially given the very small amounts, relatively speaking, of the admixtures and the impact of changing that amount.
Fantastic. Do we want to move on to the next group, Julie?
Yes, thank you, James. I'll be showing the next group questions, which is group 2, which was a mixture of the folks from the water wells and geothermal heat exchange wells. Their questions are 3 right here, and I would like to invite Julie Haas to ask about these questions.
All right. For the first question, it's paraphrased here. How do we address conditioning of the drilling fluid in the borehole prior to placing neat cement? Larry Ernst had a site that he was describing where the drilling fluid was very heavy. They didn't thin it out and they ran into issues. And I was wondering if it would be okay if Larry described that for Donald Bruce. So that.
Yeah, sure, Julie.
Okay, thank you.
What we've seen is placing neat cement under pressure. If the fluid above it is very viscous, can channelize and just go up in a single pathway along the casing as opposed to around the casing. And so I would highly recommend that the BWR documents talk about condition of the drilling fluids prior to placing specifically neat cement. Sand cement grout's a lot more forgiving, will push up just about anything, but the neat cement is very problematic with regard to very viscous fluids above it.
Donald, do you want to comment on that or add anything about, I know we prior to the TAC, when we sent out a call for questions, we did have somebody else mention neat cement washing out when being placed under water. It's kind of the other side of the coin. And I was wondering if you wanted to mention proper placement of neat cement and what you can do to combat those issues. Okay.
Hi, Larry. I enjoyed that comment and that question. And I think I understand your concern there. So an analogy would be, as you know, in what we call a slurry wall or diaphragm wall. After the excavation of the trench has been made, it's basically filled with, it consists of dirty slurry. It consists of the bentonite slurry, i.e. the excavation fluid, with a lot of sand or other materials in it. And before tremming the concrete, that material is fully exchanged. So the old materials pumped out, clean bentonite slurry is pumped in. So therefore, when you start tremming that trench full of concrete, then the material above it is lighter. You pump at a certain rate, and therefore you can displace that material out more readily. I just wonder, in your practice, is it feasible to think in terms of exchanging the drilling fluid before you start displacing it with the neat cement grout? Is that practical in the field?
Yes, well, what we typically do is we require that the drilling fluids be in a certain condition prior to running casing.
Yes.
It prevents this situation. And the situation that I used in the breakout group was an agricultural well with no oversight. And then it led to the channelization along the side of the big casing. And it's a lot, just for reference, it's a lot harder. This was an 18-inch casing. It's a lot harder to get neat cement all the way around an 18-inch casing than it is around a much smaller diameter casing.
Concur, absolutely.
so we, with this ag well that was not conditioned at all prior to running casing, the fluids were actually pumped by Halliburton, and the fluid they pumped it and it just went all up along one side of the casing, and actually the cement ended up in their mud tanks, and the well got no annular seal, and actually that well created saltwater intrusion into that location. So it's a big deal, but if you should have some type of requirement in the proper condition of the fluids prior to cementing for specifically for neat cement is imperative.
Good. I fully support that. And the other thing to think about as well, Larry, would be how quickly do you pump the cement grout? Because the last thing you want to do is to have exactly what you described there with Halliburton, preferential pathways developing or contamination of the grout, by forming little overlaps or scallops as it's going up and trapping some of the drill fluid. So that would talk to the rate of injection being not over aggressive. I mean, I don't know what the definition of that is, but in a way that wouldn't allow contamination or preferential paths developing. Now,
I completely concur. I think what we're seeing is that the one particular agency that required Halliburton to pump the cement in this well didn't have a concept of the fact that they pump very fast, and the whole process was done in minutes as opposed to hours. And so that was the real problem in this situation.
I think you put your finger on it there, because even a contaminated drill slurry, what do you think the density is going to be? Maybe 80, 90 pounds cubic foot?
I'm a pounds per gallon type of guy.
Yeah, okay, go ahead then.
But yeah, I mean, I would estimate that in this case it was above 9.8, probably approaching 10 pounds per gallon, and probably a viscosity over 60.
Okay, so 10 pounds a gallon. Okay, well, the grout is still going to be denser than that.
Yeah.
So therefore, physics is on our side there, Larry, in the sense that if we inject it at the right rate in the right place, and with the right composition of the grout, it should be able to displace upward, just like a piston from below. But the whole thing's going to be facilitated by an exchange to a lighter mix to begin with, to lighter fluid to begin with. And also, is there a way of requesting a minimum annulus width even around the big casing?
Well, it's funny, we keep going with bigger, in these particular cases, we're looking at likely having 6-inch angular spaces as opposed to smaller, just to facilitate accessory pipes and things like that. Sometimes even more. Sometimes it's as much as 8 inches to take in consideration injection pipes or other type of accessory pipes around the main casing. One thing that to consider also is that as you start getting 60 to 70 viscosity, it isn't necessarily, they're not circulating that in this particular case. So the plastic viscosity sets up and this becomes almost a pudding in the well if it's not conditioned. So you have if you look at the rheology of it, you have your different its viscosity is related to time, and after a while, the plastic viscosity gets, if it's really poor conditioned fluids, gets to the point where it is essentially a pudding or a paste.
Yep.
And so this is why it's an issue. It isn't necessarily the weight or the viscosity at the exact time. It's also what happens over the duration. But it seems like unless you have a fluorine artesian well, you should be able to put some parameters in the standards to say that your well should have there's very few circumstances where the viscosity should ever be over about 45 seconds per quart or 9.5 pounds per gallon, which are way over what I would normally specify. But I believe you could pump neat cement through that. But there's got to be some standards to address the conditions of the fluids above your TAC in order to make this work.
Yeah, absolutely. Well, I completely agree with you, Larry, in principle. I defer to you on the actual numbers that you may want to put into the document.
I'd be happy to provide more information to DWR if you want to add that information in.
Excellent.
Thank you. Thank you both. So the next question is, what is the long-term durability of grout with the additives that you mentioned?
Yeah, it's a very good question too. Let's start at the beginning then, just real quick. Super P and Wayland gum are, or say a retarder, is something that affects the rheology. These materials get used up chemically in the reaction. They don't appear anymore. So therefore, the main control over long-term durability still remains the water-cement ratio. That's the key thing, and the stability. These other admixtures and additives are short-term facilitations. They should not have an effect on the long-term set properties of the grout, including durability. The only thing to watch then is with the bentonite, if you use excessive bentonite, and so we build some cutoffs with self-hardening drill slurry and stuff like that, as you folks know. And if the water content of these mixes is extremely high, the cement content is low, and the bentonite content is high, then there is the danger of a long-term durability aspect, just because of desiccation. Simple as that. And the grout gets spongy and crumbly. The same way as if we use sodium silicate to try and accelerate the set of the grout, if we use too much of that, the grout will get spongy and will crumble. So in most of our, Julie, just to summarize, in most of our HMGs, or high mobility grouts, no long-term effect with the use of these admixtures or additives, none.
Thank you. And the last question is, please say more on destroying large ground loop systems by pumping grout through the whole system. I think they were looking for more information on the particular grout. Do you have anything to add to what you presented?
Not really. From what I understand, there hasn't been a lot of work done in this field yet. Is that correct?
Right, that's true.
Yeah. So, I mean, the basic principles everybody would know. You want a grout that's fluid. You want a grout that's well mixed, i.e. has no lumps and has good rheology. You want a grout that will not start setting up on you for the duration of the injection. You need a pump that is adequate and reliable to grout at a certain rate to ensure that the job is finished before the grout starts going off. So I think these are obvious practical things to bear in mind. I would really love to say that, you know, you could wave a wand and say, well, here's a magic grout, use this. But you can't. What I'd say is, simplest thing to do, a nice neat water cement grout, maybe type 2 with some Super P and or retarder, and you could be able to pump that for hours. Nice and simple. Mixed in a high-speed mixer, preferably.
Thanks, Donald.
You're welcome.
Great. Thank you to group 2. We'll now move on to group 3. And this was a group that had TAC members from our previous monitoring wells and cathodic protection members. And I am going to invite Debbie Spangler to express these questions. I believe there were a few other DWR folks in that same breakout group, but let's go with Debbie. Debbie, are you there?
I am, but I didn't ask the questions.
Okay.
So
that's fine. I just understand that James Albertoni had lost internet connection, and so we could have you just to express these questions to Donald Bruce so that he can answer them.
perfect. That's fine. I just didn't want to jump into the middle if there was a misunderstanding. So so number one, are admixtures are they going to have any requirements to be safe for drinking water?
Yeah, hi, Debbie. Thanks for reading that. Two aspects here. First of all, from a technical point of view, all these admixtures have been and are being used on major water retaining structures, like mainly for dam rehab and so on. They have been used, for example, in your recent dam raises over several dams. And this is the work that Tim has been following closely. So from a practical point of view, there is no problem, in my opinion and in my experience. Secondly, the issue of whether there have to be specific requirements, I would defer to James and his colleagues regarding the requirements, the statutory requirements in the state of California. But I would think that, by common usage for now, it's pretty clear that these are very benign materials.
Okay, great, thank you. Okay, so the second question is regarding to the length of time that it would inflict on a job site for allowing hydration of bentonite. So the question is, when a job time typically takes 8 hours, maybe 12 hours in the summer, how can a 4-hour cure time for the bentonite be accommodated on these small sites?
Yeah, I know. This is an issue with any of the bentonite grouts that we would use, and I'm perfectly aware of it. Didn't want to make this overcomplicated. More or less knew that we were going to get this question. And the answer is this: if you cannot accommodate at least 4 hours hydration of the bentonite, don't use it. Find another mix design, quite frankly. But 4 hours is a minimum, and as you mentioned, and therefore on a longer job that might span, say, a couple of days, something like that, you just mix up the whole thing on the Monday morning, and you just keep it bubbling away in the storage tank, and dip into it when you need it, top it up when you need it. But frankly, I would, based on what we talked about this morning, Debbie, I would say, repeat, if you cannot use prehydrated bentonite, properly hydrated, properly mixed, don't use it. Find another mix design, because otherwise you're wasting precious bentonite.
Okay, great, thank you.
You're welcome.
Thank you, folks. And I want to see, I think we have just a few more minutes. And so it could be possible that we ask the breakout group leads who just spoke, Julie Haas, Debbie Spangler, and James Walker. Were there any other questions that you thought rose to the top that you would like to pose to Donald Bruce in the next few minutes? And then we'll go on to our next agenda item.
Hey, Julie, I thought my deposition was finished now.
Oh, we're going to try to squeeze in as much as we can while you're here.
Oh, no.
So anything else from those DWR folks? Or Donald, any questions that you heard in your floating around that you thought, oh, I would, that would be important for me to answer here in the plenary?
No, I didn't want to comment or interfere in these at all. I thought it was a fascinating process that you had set up there. The only thing I'd say is I really appreciate people's patience this morning, going through all that pretty dry stuff on the grouts at the beginning. And I appreciated the questions that I heard being formulated in the different groups. I didn't write them all down because I knew that the group leaders would be prioritizing them. So I'd be quite happy to comment on any of the other questions, but again, just very appreciative of the attention and the organization this morning.
Sure. Great. Thank you. I'll just give another moment. James, yes, I see you came off.
Yeah, no, I just wanted to, I think from our group at least, we covered the questions that are applicable for Donald to address.
Okay, very good.
Thanks,
Okay.
James.
Julie, do you want to add anything?
No, I think we covered it. Yeah, I really appreciate the questions that were asked from all the groups. It's really interesting to see how much people did pay attention, Donald, through your presentation. So
That's very kind. I hope so. And again, just to confirm, that we're not trying to be smart, Alex, here and say, this is what we do in dams. This is what you should do in wells. It's simply not the point of this discussion at all. It was simply, as you required, to bring to the group's attention what is happening in a parallel industry and what the good aspects that we've learned over the last few years, if they are applicable to the well industry. So it's not an enforcement, it's just an addition.
And I just will say, because we had an extra minute, we probably don't have it anymore, but there was a comment made in my breakout group that there's a concern about how this is all going to be made practical, especially for the local enforcing agencies. Yep. In terms of the performance criteria and all of that. So we are keeping that aspect in mind as we're incorporating all of this into the draft update. I just want you to know that. And while, you know, it may change your practices and there may be additional steps, we're always trying to make it as practical and non-onerous as possible. So.
Okay. Well, thank you so much, everybody. Our next agenda item is the schedule and plan to finalize. So again, this is reorienting back to the larger picture of the process of updating the well standards. And I'm going to pass it over to Julie Haas so that she can describe this process. And then, of course, we'll go over to Erin Button with the state board. So go ahead, Julie.
Okay, thanks, Julie. And you can just forward to the next slide.
Sure.
So following revisions to the draft based on this grouting review, the draft will go through technical and legal reviews within the Department of Water Resources. Then we will release it to our partner agencies, the water boards, CCDEH, and other state agencies for a legal review. And then our publications group will help us with formatting and light editing before we present it to the DWR and California Natural Resources Agency executive leadership and the governor's office to approve prior to public review. So this gets back to what Cindy mentioned, which is because it's a bulletin, it has to be reviewed, or at least offered to be reviewed, all the way up to the governor's office. So the length of time for executive reviews varies, but right now we've estimated the public review will happen in June of 2025, so summer 2025. A 45-day public review is planned, and then it'll go back through revisions and executive reviews by DWR agency and the governor's office. We anticipate final standards will be published in April of 2026. And once they are final, we will submit them to the water boards who are going to speak about their planned process for updating the model well ordinance. We do have trainings planned following publication of the standards, a series of live trainings around the state, which we plan to record and publish online in training modules. I know that was brought up in the breakout group I was in, the need for training. So with that, that covers the timeline. I think I'm going to pass it back to you, Julie.
That sounds good. Thank you. And I am going to introduce Erin Button with the State Water Resources Control Board to talk about the update from your organization.
Great. Well, I'll take it away. So this will be relatively brief, but I appreciate everybody kind of hanging out till the end here. So essentially, you know, we're working in tandem, obviously, with DWR, but our process for the model well ordinance doesn't necessarily start until once, you know, we received a final copy of the model well, or of the water well standards. And so, so to take a little step back for some of you folks that may or may not have heard of the model well ordinance, which quite honestly, until I came to the state board, I had not heard of it either, because I was in private and I specifically focused on the well standards. But essentially, this ordinance was required to be adopted by a legislature in 1989. and it was required that the state board adopt the ordinance for water wells, cathodic protection wells, and for monitoring wells. And essentially, this is an ordinance that was then the standard, and counties or other regulatory agencies could then adopt their own no later than January 15th, 1990. So these have all been completed for quite some time. What leads us up to today is that new legislation requirements came in and required that the water board adopt geothermal heat exchange well model well ordinance. And so that's why we're in the mix today. And so we're doing this in tangent with DWR. And just for a brief once over, what exactly is this model well ordinance? Well, essentially, it's all the permitting requirements, permitting conditions, requirements for inspections, variance requirements, as well as potential enforcement and violations for not following them. So it's more of the administrative portion. So, timeline. As I said, our process technically doesn't start until after we receive the documents from DWR, and then we will update our document to include the new DWR water well standard, as well as new references to geothermal heat exchange wells. So in general, we intend to make some slight changes and variations to the current ordinance in terms of updating language. It was done in the late 80s and things have significantly changed. So we want to make sure that we update that to reflect current standards. Good example would be new privacy requirements around water well completion reports, as well as submittal procedures for those, right? That is very out of date and we have currently, that's no longer applicable. So we'll be updating things like that. And then we'll also, like I said, be adding that specific description of the geothermal heat exchange wells to the ordinance. So again, we'll start that process once DWR gives us our final copy, essentially, of the adopted water well standards. And then in the meantime, you know, we are currently working to update our current document, and so hopefully nobody's blindsided by this when we receive the final document. So we still have some time. And then as further details are made available, we can obviously push those out to folks, but in general, it should be a relatively straightforward process. So thanks.
Thank you, Aaron.
Yeah, absolutely.
Well, that brings us to the end of our group meeting here. And I just want to say it's just been such a pleasure to see many of you again and hear your voices. And this thank you to our guest, Donald Bruce, for being here. And I do want to just pass it back over to our lead, Julie Haas with DWR, to add any closing remarks.
Thanks, Julie. I also want to thank everyone for joining us today. On behalf of DWR, thank you to the TAC members for volunteering your expertise and time to this update process. Thank you, Kearns and West. It was amazing, the transitions from the plenary to the breakouts and back. I really felt like I was in a Star Trek episode. It was seamless and flawless. And I want to thank the DWR technical team. You're amazing. Our administration, so DWR executive and all the way up. And to our special guest today, Donald Bruce. Protecting groundwater is a team effort. Thank you, everyone, and we'll be in touch soon.
Thank you so much, everybody.
Thank you.
Thank you.
Thank you very much.
Thanks, Julie.
Thank you.
Thank you.
Take care. Bye.
Thank you.
Thank you, Julie.